All right, we're going to do problems 1 through 5 on review day 18. First one says, which of the following is an antiderivative of this? Again, this is an antiderivative of this if this is the derivative of one of these. So in other words, what I think is easiest here, because I don't know how to integrate that, neither do you, but we would kind of go back and say, well, if I take the derivative of these, which one of these would give me that, right? So this first one's tempting. The 3/2 goes in, cancels here. This goes to the 1/2, which gives us the square root of that. But because a chain rule, a 3x squared would pop out of this, so that's not going to work. Now this one makes you feel like, okay, well, if that 3x squared pops out, that'll cancel the 3x squared, so maybe this one's the one that works. But if you were to take the derivative of this, you wouldn't do it the way you were doing A. You'd have to do it as a quotient rule. This one's way complicated, all right? This one's tempting. If we take the derivative of an integral, you just drop what's in here inside. But again, there is that piece that says you have to take the derivative of what's here. And so if you drop this in and then multiply it by 3x squared, you'd have too much. This one, if we drop this in there, we'll have the exact same problem. We'll have to multiply by 3x squared, so that drops out. This is the only one that if we take the derivative, it'll cancel the integral. The x would drop in. We wouldn't have anything else to worry about. That's our antiderivative right there. All right, so again, not too bad once you see it, but you could get, easily, if you're just in a hurry, you could get slipped up on A for sure. This next one gives us a piecewise function. It wants to know what f prime negative 1 is. So what we want to do is kind of look at, first off, can we even find f prime negative 1? Let's put negative 1 in. The top will give us 2. The bottom will also give us 2. So at least we know we're continuous at negative 1. If we weren't continuous, then we would just pick E. Okay? But now, as far as the derivative is concerned, we have to see, well, what's the derivative of the top? It's 3. What's the derivative of the bottom? It's negative 2x. If I were to put negative 1 into the bottom, I get a slope of 2. We get a slope of 3. The slopes are not matching. That means you're going to have a sharp turn there. So you don't just pick eeny, meeny, miny, mo. If they don't match up, then we don't have a slope there. All right. This next one says we have a velocity equation of this, and we want to know how far did we travel the first time that it comes to rest. So we need to figure out, when does 2 cosine 3t equal 0 the first time. That's when we'll come to rest. That'll be our time, and then we'll have to integrate with that time. So there's a little bit of work involved here. Now, I know cosine equals 0 the first time at pi over 2. So I need 3t to equal pi over 2, and that means t is going to equal pi over 6, dividing by 3 there. Okay? So I want to take the integral from 0 to pi over 6 of this equation. All right, so the first part's okay, tricky enough, and then I got to figure out the integral of this. So I know cosine will go back to sine, and 3t is going to stay inside of it. So what I want to do now is just kind of think about this. If I took the derivative of sine 3t, it would go cosine 3t, and then a 3 would pop out. But I don't want it 3. I want it to actually equal 2. So what I need here is a 2/3. If I have that 3 pop out, 2/3 times 3 would give me this 2. Now you can do that as a u sub for sure if that's your preference, but this would be a route that you might take to save yourself a little bit of time. Now we're going to go ahead and go 2/3 times the sine of 3 pi over 6, that's pi over 2, minus the sine of 0. Now what's nice here is sine of pi over 2 we know is 1. Sine of 0 is 0, so I get 2/3 times 1, which is 2/3. Now, a lot of little steps here. This is not an easy problem at all, especially in the moment. But hopefully you follow the logic here. When does the velocity equal 0? That's when it comes to rest. Then what's the distance traveled between there? Integrate, use a u sub or whatever, and then evaluate from there. Okay. This next one gives us a derivative equal to all of this, and they want to know which of the following is true. Now, first off, it's good to note that 2, 3, and 4 are critical numbers, right? They all make the derivative equal to 0. So we're going to go ahead and test them, 2, 3, 4. And what's good also to know is that when you test these numbers, you don't have to necessarily pick a number. You just have to know what's going on in between there. So for example, if we were to put something less than 2 in here, then this would become negative. This piece would be negative. This piece would be negative. They're all less than those numbers. So I get negative, negative, negative. Now, the sneaky part is this squared. Because we're squaring this, this will always be positive. No matter what you put in for x, this piece is going to be positive, right? So in other words, if I put, say, like a 0 in, I'm going to get negative 2. I'm going to get negative whatever, and I'm going to negative, positive, negative. That'll be giving me a positive right here, okay? If I put something bigger than 2 but less than the others, then this piece will turn positive. This, again, stays positive, but this will stay negative. So positive, positive, negative will give me a negative here. If I put something bigger than 3 but less than 4, nothing changes, right? It's still positive, positive, negative. So that'll be negative here. And then if I put something bigger than 4, now all of a sudden this is positive, positive. They're all now positives here, okay? So that means 2 is a relative maximum because we have a switch from positive to negative. 3 is nothing, and 4 is a relative minimum. So we come over here, a relative max at x equal 2, that's true. A relative minimum at 3, nope. A relative max at 4, no, it's the other one. So A is the only one that works out for that. Okay, so you have to test it out in there and see and be real careful because you might assume something here or not read carefully. Make sure you read everything carefully when you take your test. All right, this one here gives us a table and wants us to use a trapezoid sum. In fact, it's already done the trapezoid and says that it's got an answer of 52, but there was a missing value in the table. They want to know what k would equal, right? So if you kind of think about trapezoid rule, you would go 4 plus k times the distance between 2 divided by 2 plus k plus 8 times 2 divided by 2 plus 8 plus 12 times 2 divided by 2. Now the nice thing about these is they all cancel. So I get 4 plus 8, which is 12, plus 8 is 20, plus 12 is 32, plus k is 2k, and we're told that that all equals 52. So when you subtract, you get 20 divided by 2, and we end up with k equal to 10. So not too bad on that one there.